So, hi everyone. It's my pleasure to be with you today and finally give a talk in person. And thanks to OEFI organizer for having me today. So, I'm pleased to share some results about my research on the analysis of on-farm research network and data visualization and statistical approaches to test the efficacy of management practices. So first, I would like to define what I call a farm research network in my studies. So it's a collaboration between local farmers and the research community, like extension services, university, and local agronomists. And farmers implement field-scale trials, and they manage that with commercial-scale equipment. And they all follow the same research protocol. And the main goal is to evaluate different management practices and over a wide range of environments, and also to improve productivity and helps to guide management decision. So that's an example of on-farm research network who was managed by the Iowa Soybean Association in the Midwest. So the dots represent the on-farm trial location. And as you can see on that figures, that's the overall view of one on-farm trial. When you have two colors representing the strips, the control and the treatment. And in central Iowa, a common field will be about 32 hectares. And for on-farm trial regarding the management practice you are looking at, the trial will range between 2 to 11 hectares. And that's a scheme of the experimental design, which is a replicated strip trial design, where you have the treatment of interest, which can be a crop related to crop production, crop management, or plant nutrition. And the control will be untreated or the standard practice in this region. And we have at least 3 replicates per on-farm trial. So there is current limitation in the analysis of on-farm research data. Most of the time, data are analyzed through individual reports, which it's like a summary for one individual field part of the network, where you can have access to descriptive results, yield average by strip or the average by treatment or by strip. Like you can see on that figure, you have the treatment and the control, and you have access to the yield per strips. And you will also find some elementary statistical analysis. But by doing that, we don't have access to the global synthesis of all the on-farm trial network. And the comparison between on-farm trial can be misleading. It can be biased because you are looking at different statistical analysis from different models. And you don't have also access to the yield response, no explanation about the yield response using covariates. So in that context, we need to develop appropriate statistical methods to simplify multi-trial analysis for on-farm research network, and also to disseminate the results more efficiently, rather than just a static PDF report. So in that context, we have 3 research questions. The first one is, what is an appropriate statistical analysis for synthesizing on-farm research network data? The second one is related to the data visualization. So how can results be disseminated to the on-farm research network community? And finally, as we are interested by on-farm trial, we also wonder how do on-farm trial and small plot trial from research station compare in yield outcome. So let's dive to the first research question about the statistical analysis. So we develop an analytical framework. So that graphic is a little bit busy, I know, but what we have to remember is like we have 4 parts. The first 2 parts are related to do the description of the environmental trial condition, and the second part is about the analysis of yield response using raw data and simple statistical graphic. And then we have the third part is about the statistical modeling, and I will focus on that one for my next slides. And the last one is about the yield response variability, including covariates. So we implement this analytical framework on 27 and 24 management practices on soybean and corn in Iowa, with Iowa Soybean Association. So it's important to notice that when you use on-farm research network, you have the between trial variability, which is explained by different environmental conditions and farmer management practice. But also we have a within trial variability because the strips cover a wide portion of the field. So we have heterogeneous soil and field topography. So we need to account for those 2 sources of variabilities in our analysis. So as we are looking at the efficiency of a management practice, we are using a yield ratio, which is the yield in the treatment divided by the yield at the control. We use a random effect model where trials are defined as random because trials are a representative samples of the other trials in Iowa, field in Iowa. And also by using random effect model, we also account for the two sources of variability between trial variability and the within trial. And also it will returns the mean yield ratio, mean yield response at the network level, including all the on-farm trial and also the trial for each individual field. So I will just give you one example for today. So it's related to foliar fungicide on soybean, where 43 trials were involved. So they use a replicated strip trial design, where you have the foliar fungicide as a treatment and the control was untreated. For this network, we have between 3 to 11 replicates. And that's the main output of the random effect model. So I will just explain step by step. So we have on the x-axis, the yield ratio. So if it's higher than 1, we have a yield gain using the treatment of interest. If it's lower than 1, we have a yield loss. On the y-axis, the black point represents yield response for each individual on-farm trials. And the horizontal line represents the uncertainty. If it's cross the line 1, the red line, it's not significant. In that case, we had 12 on-farm trials having a significant positive yield response over 43. And at the bottom in red, we have the mean yield ratio, which is the response at the network level, including all the on-farm trials. So that's why also the uncertainty is smaller. So in that case, in range between 1.02 to 1.05, which means at the network level, we got a yield gain between 2 to 5%. So the main takeaway of that first part is like that framework can be adapted to different on-farm trial data set, not just the foliar fungicide I just presented. And it helps to better understand the overall effectiveness of a management practice. And it also helps to guide decision making, but we need to include also proper economic and agronomic context. For the second part related to data visualization, we want to develop a more practical way to disseminate results, and we want to simplify the analysis of multi-site and multi-year summaries. So we developed a web application called ISOFAST. You have the link online, and you can just type ISOFAST on Google. You should get it pretty easily. So that's a screenshot of the interface of ISOFAST, which stands for Interactive Summary of On-Farm Trial. And it was developed through our studio using Shiny. And on the left side, you have the menu for the user. So it was developed mostly for farmers, agronomists, and researchers at university involved in the on-farm research community. And the user can select corn or soybean and then the treatment of interest. Like for example, in that case, we are on soybean, we select the row spacing, and then you have access to sub-items. All those graphics come from the data analytical framework I just presented at the very beginning. So, and on the right side, you have the output. So in that case, it's a map, the trial location. I have a couple of animation of GIF just to present you quickly the interactive features people can do with that tool. So for example, for the map, you can zoom in, zoom out, and when you click over a data point, you have access to extra information. That's how we represent the output of the random effect model, where the user can select yield change, which is the yield ratio converted in percent, or the yield difference, because farmers really like to play with yield difference because then they can convert that into economic. And at the bottom, we have also in boxes giving some key results in case people get lost in the interpretation of the graphic. And then when we want to have some covariables, we also have some interaction, and people, for example, in that one, people can relate the yield difference as a function of the rainfall and select the months of interest. So we do believe ISOFAST simplifies the understanding of statistical methods and summarize multi-site and multi-year data, and it allows for self-assisted exploration of the results. My last research question, it's about the comparison between on-farm trial and small plot trial. What I call small plot trial is like small scale and most of the time run into research station. So we wonder how do output from on-farm trial and small plot trial are similar or not. So we want to evaluate the impact of the experimental scale on the foliar fungicide on crop. We choose that management because we were able to gather a lot of data for foliar fungicide. So we did a literature search where we were focusing on corn and soybean for foliar fungicide and at least have the control which is untreated. And we need to have access to the yield. It can be aggregated or the raw data per replicates. And we exclude seed fungicide. So we got a total of 978 trials in the database. Data range from 1999 to 2019, and we have over 2,000 value of mean yield ratio. I mean the mean across the replicates. So we ran a statistical model, and we found no statistical difference. As here you can see on that table, like the mean yield ratio for small plot trial and on-farm trial, OFT for on-farm trial and SPT for small plot, on soybean and on corn, and they are fairly similar. So we have no statistical difference between mean yield response for the two experimental scales. But we found a bit in trial variance was higher in small plot trials, and we could explain that by a larger diversity of environmental condition and practice tested through small plot trial rather than on-farm trials. So thanks for your attention. And I will publish also a proceeding paper when you can find again this research.